All right, so today we're going to continue with SQL. We'll pick it up right from where we left off last time with a little bit of a review. Remember that we are online, so if you have any questions, make sure that you post to Piazza or to the YouTube live stream. But otherwise, I want to remind ourselves of what we were working with here. This is the video game database that you saw in a flattened form on your first assignment, where you had to process it and ask how many games each publisher had, how many how many platforms was each game available on, etc. And this is the normalized version where each one of those columns is separated out into its own table. In this case, we've got four tables. We've got the publisher table, the game table, the platform table, and they're all related. Relational database management system, right? They're all related through foreign keys. Remember that we've got a publisher ID over here. That's the child table. This is the parent table, and you can't have orphans. You have to have for a game record to exist, you have to have that publisher ID, right? Likewise, we've got a many-to-many relationship here so that one game can appear on multiple platforms and vice versa. One platform can have multiple games. And finally, we have a one-to-many relationship here. So we've modeled the idea that you have one publisher can have multiple games, but that one game only has one publisher, right? So it doesn't work in reverse. Now, if you wanted to model that, you could by creating a join table in between, just like we did over here, okay? We left off with talking about data projections, where, go all the way back to assignment 1 now, where we asked how many games does each publisher have, right? And so we introduced two, or actually one query to do that, right? So let's go ahead and describe the game table, right? And visually, we've got a game ID, a name, and a publisher ID. And we've got the game, again, visually it's over here in the ER diagram. What I want to do is I want to produce a query that will give me all of the all the publishers, right? Ideally their name, but we haven't talked about that yet. Ideally, all the publishers along with a count of the number of records that they have. So if I just select everything from the game table, what do we have? We have all these game IDs in order, all these games, and GTA 1 through 4 has all been published by the 6, which is probably Rockstar Games, but I don't know that yet because I don't that's in a separate table. Right? What kind of query did we make to count up 1, 2, 3, 4? Do you remember? Again, it's a data projection. If you take a cube, a three-dimensional object, and then you project it down onto 2 dimensions, you get a two-dimensional object. That object is called a square, right? Well, it depends on the angle, but that's the idea. So visually what we're doing is we're going to take, say, a title, an author, and the number of copies, and we're going to project that down by grouping them. Group them by the author, right? So that all the Norman Mailer books are all together. All the Douglas Adams books are all together. And the single Orson Scott Card book here is all together. And then I want to sum up all of their numbers of all the number of copies. Right? That's a data projection. It's taking this three-dimensional data and it's projecting it down onto 2 dimensions. You lose one dimension, but then you can aggregate the other dimension. Right? What the dimension here that we're losing is the title. Right? The dimension that over here that we would be losing is the games. I don't want a list of games. I want a list of publisher. Publisher 6 has how many games in this database? Right? So let's go ahead and rewrite that query. I think we did it last time, but let's remind ourselves what it looks like. So I will select the publisher ID and a count of everything, right? Or you can be more specific. I'll count the number of game IDs, right? From game. I'll go to the next line here. From game, where, and then here I group by. What do I group by? Oh no, it was working before. All right, I should have kept this up. All right. been persnickety this morning, and so I'm going to have to go to the command line instead. By the way, if you're interested in doing everything in the command line, you can. It's MySQL, and then you specify your username, and then P because I want you to prompt me for the password, and then I want to use my database named after me. It will prompt me now for a password. I'm going to enter my password. Oops, that's the wrong one. I discourage you from doing this unless you absolutely have to, because when I tried to erase, or when I tried to do some unsafe things like, say, delete from game over here in MySQL Workbench, did it let me do that? Nope, it was in safe mode. Guess what? The default over here is non-safe mode, right? Dangerous mode? I don't know. It's not a mode, right? The safe mode is shut off here, okay? So again, let's select all of the games. Select star from game. There we go. There's what it looks like from the command line, okay? Instead of that nice Excel-like table that I can manipulate and screw around with over here in MySQL Workbench, I get this list right here, okay? So let's go ahead and select publisher ID, and then, come on, select publisher ID, and a count of the number of games, game IDs, from game. And you can go to the next line, right? As long as you don't end it with a semicolon, it allows you to continue typing. So from game, group by publisher ID, right? And let's go ahead and execute that. And we see here, there's that publisher ID 6, right? They have how many games? GTA 1, 2, 3, and 4. Right? And so I get a count of the number of games that they have. What if I did something else? What if I did, say, a count of, I don't know, publisher ID? Right. I would get the same thing, but why? Because, well, for every publisher ID, there's a game ID. But what if I did something different? For example, what if I grouped by the game ID instead? What am I going to get here? What do you think? 111111111. Why? Well, I was grouping by the games. Select everything from game. There we go. All the game IDs are unique because it's the primary key. That's the purpose of a primary key. And so if I group them all together, I just get this result here. Apparently we went crazy and went and inserted Pong multiple times there, right? Oh, actually, no. What did we do? We shut off safe mode, and then I renamed all of the games after a certain amount, all Pong 2, right? All right, so that's projection. You are taking a higher dimensional database and you are projecting it down onto lower dimensional data so that you can aggregate, you can count, you can take an average, you can take a sum, et cetera, right? You can do something else entirely. For example, I'll go back to publisher ID here, and instead of counting the publisher ID, what if I did a sum, like I did, or like this example right here, that this would have been a sum, right? Let's see, where is it? Yeah, a sum of the number of copies, because I was interested in how many total copies of Norman Mailer books do I have. Over here, does the sum make any sense? You're summing up a bunch of key values. Okay, that gives you numbers, but is that meaningful data at all? No, right? All right, great. Let's go ahead and go back to the correct one. Oh, that's not the correct one. I want to group by publisher ID. There we go. There are all the publishers. Rockstar Games here has 4 games. But I only want to know the publishers that have published more than one game. I don't care about those one-hit wonders right there, right? These publishers, whoever they may be, that have only published one game. I only want results if they've got 2 or more games. Right? So normally, how do you do that? From game, you would do that with a where clause, right? Where the number of games is greater than 2. Can I do that in this case, though? Do you see a column called number of games? Nope. So I don't know anything about number of games. So the first step here is to give that column a name, right? How do I give that column a name since it doesn't have a name? Its name is count publisher ID. I want to give that a more sensible name. As, that's called an alias, number of games. There we go. And I get the same results as before, but again, I want to exclude these last 4 here. So if I did a where clause, would it work? From game, where number of games is greater than, say, 1. Strictly greater than 1. Right? It doesn't know it, even though I've given it an alias. Why is that? Is that a real column? No, it's what we call a derived column. Right? The result will have that column, but guess what? I'm asking about that column before I've grouped it to create that column. So I need something different. Instead of a where clause here, I'll go ahead and get rid of it. Right. Go back to the original here. I need to do it after that derived column has been created. And that's going to be another keyword here. Having number of games greater than 1. Right. There. Now I've gotten rid of those last 4 there. Right. Again, it is the projection. Are you filtering out the results before or after the projection? With a where clause, you're doing it before the projection. Right. The having clause is done after the projection. Right. So, questions on that? Otherwise, I'll make sure that you have this in the notes since it's Aqua Data Studio. It's an old platform that I used to use instead of MySQL Workbench because I wasn't footing the bill at the time. All right. Anyway, this is a query to that the where clause filters results before a projection. Right? The having clause filters results after a projection. And you can do multiple projections if you want to, but I'm not going to get that complicated here. And unfortunately, that doesn't look very good because I have copied it from the command line, which is all one line. So I'm going to go ahead and go down to the next line here. You can do this because white space does not generally matter in SQL. And so you can go group by, having, and there are plenty of style guides out there that tell you break on the keywords and do, and do proper indentation, whatever. Align all of those columns, select this, and then the next line, this, etc. As long as you're consistent about it, we're not going to care. Right? But you should break up long lines so that you don't have that big giant line that it wouldn't even fit on the screen here. Okay. All right. Any questions so far? Then, let's look at this result again. I told you that 6 was Rockstar Games, but who's 11? I have no idea. Where is that data? Where can that data be found? Who's publisher ID 11? I'm over here in the game table. Is that information there? Nope. Where do I have to go? Over to another table. In other words, I have to take information in 2 different tables and combine them somehow to get new results. I have to join them together. And that's where a join comes in. Let's visualize it here. Here we go. So I've got a student table and an email table, right? And presumably one student can have multiple emails, right? You have multiple emails, whether you use it or not, whether you like it or not. You've got a UNL email, you've got a Huskers email, you've got a CSE email, of course your Gmail account, etc., whatever else you have, right? What I have here is a student table. I've got 4 students, and then I've got 4 emails. Some students have multiple emails. Other students don't even have any email, right? What I want to do is I want to join these 2 tables together so that I know that Castro has that email, Rizzo has that email, and then Sandberg has those 2 emails. Who's left out here? Dale, right? Dale does not have any emails at all, right? That's called joining those 2 tables together. I'm taking this table, this left table right here, and I'm joining it to this right table over here, joining them together. Right? So let's go ahead and try it over here. Let's go ahead and try it first with the publisher and the game table. I want to combine both of these tables together. Right? So select everything from game, and the keyword here is join. Right? I'll go ahead and go lowercase here. Join publisher. Now, how am I joining them together? Well, let's go back to the schema. How should they be joined together? What is the relationship between these two tables? The publisher ID, right? So if I've got a record over here with this publisher ID, that should match this publisher ID over here. Just like in our example here, how did we go about getting this first record, right? Or this Castor record? Student ID 1234. That matches with the student ID 1234 over here. Right? Rizzo's 5678 matches with this 5678 over here. And then Sandberg 9988, 9988, 9988. But what about Dale? There is no 1122 over here. Right? And so there was no there was no record to join together on those. So ideally, I should be joining through foreign keys. What happens when I don't? Let's make it a little bit bigger and then increase the size of my window. There we go. What kind of results do I get now? Every single game is repeated for every single publisher. Right? Why is that the case? Well, to understand that, we need to dive in a little bit into discrete math here. And hopefully you're taking 235 right now, and you've gotten past sets and everything like that. So let's go ahead and review a little bit of math. We're not going to get too deep into it. But suppose that I've got this thing called a set. Right? A set containing A, B, and C. Suppose I have this other thing called another different set, 1 and 2. Right? So I've got another set. I've got a set A. What's the cardinality of A? Do you remember what cardinality is? The size of the set, right? So 3 on the first one. The size of B is what? 2, right? So its cardinality is 2. Now, hopefully, I'll ask you, have you seen this yet? Right. It looks like times, and that's exactly what the LaTeX is. What is that there? Cartesian product, or another term is a cross product. Another term is cross join, right? Or there are a couple of others too, right? It's you're joining those two sets together. What does it look like, by the way? It produces another set, a set containing what? Pairs, right? The first one, A, is paired up with the first one in the second set. The first one is also paired up with the second one in the set. So I've got A1, A2. What else is in there? B1 and B2. Right. And finally what? C1. C paired with 1. And then C paired with 2. So the cardinality there of A was 3. The cardinality of B is 2. What's the cardinality of A cross join B? 6. Why is that? For each element over here, 3 times 2, we've got 6 elements here. That's what a cross join is. And that's what I just did over here. Right? Remember that tables results are sets, or you should think of them as sets. And so if I'm taking every element over here in this set and every element over here in this set, and I'm joining them together with no other qualifications whatsoever, then I've got just a regular old cross join. How many games did I have? Select count of star. Oops. Come on. Select count of star from games. Or game, excuse me. 24 games. And how many publishers did I have? There we go. 16. So how many results do you think are right here? 24 times 16. Somebody take out their calculator and count that up. And while I count them over here, and we'll see who wins. So 16 times 24 is 384. Right? Right. Say what? Oh, okay. All right, so we've got, this is a complete join here, right? For everything, for each element over here, we're joining for every element over here. Right? That's not what I want. I designed this database with foreign keys, proper foreign keys that define the actual relationship that makes sense. Pong 2 being published by Bethesda doesn't make any sense, right? So what should the way that I should be going about this is to specify how you want to join them, right? So I'm going to go ahead and select everything from game, join publisher, on a key value, game.game ID, or sorry, publisher ID is equal to publisher.publisher ID. So this familiar dot operator that you've used before in, say, C, you've used it in Java. If you've got a class dot and then a variable or a method or something like that, right? It's a you're traversing a hierarchy. I've got the name of the table, game, dot, and then the name of the column that I want. And only when the publisher ID is equal to that publisher ID over in that table will it produce that result. Now you see that I'm not getting those 384 values, right? I am only getting GTA 4 published by Rockstar Games. That makes sense now. What was Bethesda? Where is Bethesda? Or I guess we didn't do a Bethesda, did we? Oh well. Lego Star Wars by LucasArts, right? That makes sense. If you go and start joining on things that don't make any sense, for example, instead of publisher ID, what do you think would happen if I tried to join on the name? Or what is the interpretation of this? Publisher ID or publisher.name. I'm going to join these two tables together, but only when the publisher name matches the game name. I'm not going to get any results there at all because there is no game named LucasArts. That doesn't make any sense. And there is no publisher named Katamari Damacy, right? So you have to join on how you design this database, okay? All right, questions so far? No? All right, I'll make sure that you've got this in the notes later on. Unfortunately, since I don't have MySQL Workbench working, and yep, in fact, it completely crashed. Yay. No, it didn't crash. It just didn't, lost its connection, unfortunately. Hopefully you're not experiencing that, but I have put in a ticket with the sysadmins today. Anyway, let's go back to the one that does make sense. Lots of typing. I don't like typing. You can alias an entire table if you want to. Instead of retyping game every single time, you can go ahead and go as G. And then over here, instead of retyping the entire game, you just use the alias. In fact, this is such a common operation that you don't even need to use the keyword as anymore. Same thing here. And then I will also abbreviate or provide an alias for the publisher, right? Join P on those. Okay, there we go. Oops. I shouldn't have. I erased too much, right? Publisher P. There we go. Right. Lots of repeated data too, though, right? For example, the publisher ID in the first table is matching the publisher ID over in this table, and I've got duplicates everywhere, and maybe I don't even need to use those duplicates. How can I solve that problem? By being judicious about which columns you're choosing. Don't choose all the columns, star, that wildcard operator. Only choose that which you care about, right? So g.name, comma, p.name. I just want the name of the game and the name of the publisher. And I get something that looks like this. Except what's the problem now? I've got two columns with the same name. If I were to write a program that connected to the database and wanted to perform this query, and I wanted the name of the game, are you going to be able to disambiguate those two columns? Probably not. So yet another solution is to provide aliases on the columns as title, because that's what a game name is, and as publisher or company. I'll do it that way. So it's completely different. Title and company. Okay. Questions so far? No? All right. Do you remember that we had a bunch of publishers that publish no games? Do you see them here? No, why? Take a look at this query again. Where did I start my query? I started it at the game table. And then I joined, here's the game table, then I joined the publisher table. In other words, I went from this table to this table. I was going right to left. Right? Let's go the other way. Let's start at the publisher table and then join over to the game table instead. So select everything from publisher, P, join game G on P.publisherID is equal to G.publisherID. And again, another note here, why am I not having to go back for every single time? And what was the primary key again? Right? What was the name of the table again? Right? Why am I not having to do that? Because I've got a consistent naming convention, right? Just slap on ID to the end of the name of any table. All tables are singular, etc. Right? All right, there we go. All right, so now I'm going the other direction. You see that I've got the publishers here, and then their games. Except that I don't see any publishers that don't have a game. All the publishers here have a game, right? Remember that there were like 14 publishers, but only 10 of them had actual games in our database. Why don't we see them here? For the same reason that we didn't see Dale Sweem, that's how you pronounce that. Anybody follow baseball? No? Okay. I think that he's the manager. No, he was the manager of the White Sox, and then they fired. He's been fired many, many times by different people, by different teams. But anyway, I think he was the manager for the Cubs 1 year, and I left him out of here because he was fired, and he's the one with no email because he was fired, right? So where is he? Right? He's not there because we did a regular old join. What I'm going to do now is what's called a left join, right? A left outer, it's called a left outer join. Don't worry about that. You can go ahead and drop the outer and just use left join. So the idea here is that if you start at this table, you have Dale Sweem, 1123, 22, and it doesn't match anything in this column over here, but I still want to preserve it because I want his record over here so that I can see that he has no email record. Right? In other words, I don't want this table. I want a table that looks something like this, with all of the other records normal, but now I've got Dale Sweem, or his last name at least, and then he has a null email record because there is no email. Right? This is called a left join. It preserves records in the left table. So if you've got, you're reading it left to right. So here's the left table, here's the right table. If you left join to this table, it will preserve all of the records over here. So let's do that with the publishers. Exact same query as before, but instead of a regular old join that loses information, we will do a left join to preserve information. Now, do you see Sony, Square Enix, and Sega are all preserved even though they don't have any game records whatsoever. And the fourth one down here, initially it was Bethesda and four in the original database Blizzard. And then we added our own Bethesda and Foo games here, apparently. Right? So now there are 6 publishers with no game records whatsoever. Okay. Imagine being a Cubs fan? Absolutely. 6 years ago. Unfortunately, no fans are going to be happy this year. All right, so that's a join, right? You can start with a full join. This is a full outer join or just a Cartesian product or a cross join, whatever you want to call it. We call it a cross join because of this symbol right here. It's a cross, right? You're crossing them. But you can then winnow that down to things that only make sense with respect to your primary keys and your foreign keys. And then, of course, you can preserve records using a left join instead of a regular old join. And by the way, you might be thinking about it, and yes, you're right. There is a right join. This query, I started at the publisher table, and then I went over to the game table. I did a left join on it. You can go the opposite direction and do what's called a right join. Now, if I select, so there's the results from before. Select everything from, and here I'll start at the game table, and then I'll go right instead. Select everything from game G right join publisher P on g.publisher ID is equal to p.publisher ID. And we get the exact same results as before, but there we go. There's Sony Entertainment, Square Enix, and Sega, but those two tables have been transposed here. Generally, order doesn't matter, but if you do a left join, then you are reading left to right. If you do a right join, you are reading right to left, which is why if you're going to do something like this, you probably, do we read right to left naturally? No. So usually I just go with a left join. But there are situations where you would want to go back and forth. Right? To do that, let's go ahead and establish a goal for ourselves. Right? So my goal is to flatten the entire data model, right? And make it pretty. Right? In other words, I want to reproduce assignment 1, the data from assignment 1. The data from assignment 1. Remember when I gave you the CSV file? It was already a flattened model. I want to go now full circle and go all the way back to that. So I'll start at the publisher table. Then I'll join over to the game table. I want to get all the platforms that those games are available on. So I want to join to the availability and then over to the platform table. I want to take and join all 4 of these tables together in one big data dump. So let's go ahead and do that. Let's see. Select everything initially. We're going to refine this from publisher P, join game G on P dot publisher ID is equal to G dot publisher ID. Right? Then I can join again. If I'm going from the publisher table to the game table, and then over to the availability table, how do I join there? What brings these two tables here together? The game ID as a primary key in this one, and then the game ID as the foreign key over here in this one. So join availability A on a.gameID is equal to g.gameID, right? And then I'll join again. Join back over to the platform table. P on a.platform ID is equal to p.platform ID. Right? And before I execute that, let's go ahead and make sure that that's correct. That I've got a platform ID over here, and that relates it to a platform ID over here. Okay? Does anybody see anything wrong with this query, though? The aliases, right? How many aliases do I have now? P for publisher, G for game, A for availability, and then P again for platform. Do you think you can reuse the same alias over and over? Nope. Right. It's not unique. So I'll go ahead and say PL for platform. PL, there we go. And now I was able to do it. Of course, I'm getting all of the data in the entire database, including duplicates of all of the foreign keys and primary keys. So again, let's winnow this down. I don't want all that information. I just want the relevant information. I want the publisher's name. I want the game's name. I want the published year, and I want the platform name. So p.name, comma, g.name, comma, a.publish year, comma, platform pl.name. There we go. Starting to look like that data model that you started out with in assignment 1. What about those column names though now? Name, 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 right? 3 different columns with the same name. How can I solve that problem? As title, right? G.name as, or sorry, that's publisher, right? Pub, or company, we'll say, company, as title, right? I don't need to do anything with publish year except that when I do it like this, I do, well, at least from the command line, it is doing publish year, but sometimes it'll do a.publish year. So I will go ahead and say as publish year, or year, let's say, year. And then pl.name as system. There we go. Now I've got company, title, year, system. I don't know what we used in the first one. I don't think that they had headers. All right, but in any case, there we go. Is that all the records? Remember, we had 6 publishers with no games whatsoever. And you had that in your first assignment. You had some publishers with no games. You had some games with no systems. You had games with multiple systems, et cetera, right? And the trick was to process that file and get an accurate count of all of it. So what do I need to do to preserve all those records again? Instead of joins, what should I be doing? Left joins. All the way over. Left join. Left join. And you can see why we use MySQL Workbench, right? Left join. Right? And there we go. Right? Those records with no games are preserved. All the values end up being null. When we dumped this to a CSV file, we just used an empty string to represent null instead. Right? Is that everything? So let's review where I went from. I went from the publisher over to the game table, over to the availability table, over to the platform table. I went left to right. What if I have a platform with no game record? I don't even know if I have that data, but do you see any data like that at all? Do you see a system with a null company? I don't. So, highly suspicious. There's probably a platform, for example, I think I put in like a Vive and also an index, a Valve index. And I think that those are platforms with no games in this table right now, or in these tables right now. I want to preserve those records. How do I preserve those records now? Instead of going left to right, what do? I need to go right to left. So let's go ahead and do that query. Right? Let's see. I'll do everything, but instead of starting at here, I'm just going to grab this. Select all of this stuff as year from, and then I'll start typing. There, publisher PL from publisher PL. From as system. Okay, there we go. From, and I'll start at the other end, right? I'll start at platform. From platform, PL. I'll preserve the same aliases as before. And now if I'm going right to left, I don't do a left join. What do? A right join, right? And I'll go over to the availability A on A dot platform ID is equal to PL dot platform ID. And then I'll do another right join to the game table, game G, on G dot game ID is equal to A dot game ID. Right? And then I'll do yet another right join to the publisher. P on P dot publisher ID is equal to G dot publisher ID. There we go. Now, do you see any systems here? Oops, did I screw it up? I went from platform to availability to game over to publisher. Right? But I am getting plenty now. Oh, sorry. I should have done left joins. If I go right to left, I still do a left join. Left join. All right. I don't want to retype this, so I'm going to go immediately to my, where are you? There we go. My notes. And I'm just going to steal it. There we go. This is what I want. All right. There we go. All right, now do you see the Vive, the index, and the Oculus Rift? Again, that here, I'll scroll up to look at it here. I started from the publisher, and then I did a right, so I did still go left to right, but I did right join so that I right join, preserving records on the right-hand side. Left join preserves the records on the left-hand side. So if you do go right to left, then you can do left joins. It's just left to right, right to left. It doesn't matter, right? You just have to be consistent about it. And then I got all the platforms like Vive, Index, and Oculus Rift without any game records whatsoever. Right? Is that the end of the story, though? All right, so let's go back up to the original. Oh, come on. This one? Nope, this one, nope. All right. Come on. All right, clear? Can I clear? No, I can't clear. There we go. If you want to, at the command line, you can go Command K to clear out the console. Here, I'm going to go back to the original here. That's going left to right. So I've got all the publishers, and I preserve all the publishers with no availability records. Right? Naughty Dog, Bethesda, Foo Games, and Mojang here do not have their games available on any platform. Right? I want to combine those two. Right? I want to go left to right, preserving all of those records, and I want to go right to left, preserving all of those records, and then I want to combine them together into one. With respect to sets, right? What operation is that? Oops. If I've got two sets here, set A and B, A versus B, how do I combine them? What are various ways of combining two sets here? A what? A. What is that symbol right there? A union, right? What's this set? What's this one? Intersection, right? You can do either one, but in this case, what I want to do is I want to union them together. So all together here. Let me go ahead and cut and paste this. Right? Here's the first one that works left to right. Here's the second one that works right to left. And what do I have right in the middle here? Keyword union. It's going to union them all together. And now I've got preserving both directions. I've got all those games, or I've got all those publishers, like Sony Entertainment here with no game records whatsoever. And then I've got all of those platform records with no games. Right? And here's one instance in which I have to work both directions if I want to preserve all of those records and flatten the entire data model. All I have to do now is dump this to a CSV file, replace all the nulls with empty strings, and you have the data from your first assignment. Right? But everything that you did in your first assignment, the dozens, maybe 100 different lines of code for Java, can all be achieved with one line of SQL now that we have it in a proper relational database management system. Right? In fact, what were the exercises that you did on your first assignment? List all the publishers along with the number of games they have. I think that was one, right? So select everything from publisher, P, join game G on G.game ID, or no, publisher ID, is equal to G.publisher ID. Sorry, what? Oops. Darn it. G, and so P. It doesn't matter. There we go. Is that the output we were expecting? Rockstar Games should be associated with 4. Right? So what do you actually want? You don't want every single column. You want the p.name as publisher, and then you want a count of something as number of games. What is that something? What are you going to count here? Are you going to count the title? Nope, that's not distinct. This would end up coming up with Atari gets credit for 4 games because there are 4 copies of Pong over here, Pong 2. Right? What about Rockstar Games? They would end up being, well, yeah, these are all distinct, GTA 1, 2, 3, and 4. Right? So if they're distinct, then they will count as 4. Right? So what should I be counting here? What uniquely identifies a game? I want the number, I want each publisher along with the unique number of games that they've published. What uniquely identifies a game in my database? The game ID, the primary key. So g.gameID. There we go. Oops. And now what do I need to do to project down? If I'm going to aggregate this. Why did I get 24 there, by the way? How many records are here, do you think? 24. Why was it LucasArts? Because they're the first, right? The first record it finds, then it counts all the other records. Because I didn't project it. What's the keyword for projecting stuff? Group by. And what am I going to group by here? I want all the Rockstar games to be grouped. I want all Nintendo to be grouped. What uniquely identifies a publisher? Publisher ID. So, group by p.publisher ID. There we go. Now, there's LucasArts with 3. There's Rockstar Games with the 4. But again, what are we missing? The ones that don't have any. Right? Why? What kind of join did we just do? A regular old join. What should we have done? A left join. And there. I finally get Bethesda with 0 game records whatsoever. All the others are still correct, right? Nintendo here with 4, Rockstar Games with 4. But now I've preserved all those records. And because null counts as 0 when I sum them up, I get the expected results here of it being 0. Right? What was the second one that you did? Was it number each platform the number of games that it's on? Okay, or each game the number of platforms it's on. Okay, all right. So for each game, I want the number of platforms that it's on. So what would that query look like? Select everything from game, for now. Join to the availability. Join or left join, because if it's not available on any system, I still want to count the zeros. And then, do I need to go all the way over to the platform table or not? Nope. Why? The platform IDs are already here. If you sum up the platform IDs, that's how you uniquely identify a platform. So let's do it with just 2 tables. Select everything initially from game, G. Left join to the availability table, A, on g.gameID is equal to a.gameID. Right? That'll get you a lot of data. I don't want all that data. Right? I just want the name of the game and the number of platforms that it's available on. If it's null, that'll end up being 0. GTA 3 here is not available on any platforms. GTA 4 is available on 2 platforms, whatever 2 is and whatever 7 is. So remember those 2 as test cases here. GTA 4 and GTA 3 should be 2 and 0 respectively. So I'll select the g.name as title, and then count of something, right, from game G. So what do I want to count here? The number of publishers, so that would be, or sorry, publishers, platforms, so p.platform ID. And if I do it like this, I will get 1 single record. The first one, platform ID. Oh, it's a.platform ID because I called it availability A. It doesn't know what P is. There we go. So GTA 4, that was the first one that it found. All 23 records are counted towards it. What do I need to do? Project it properly by grouping it by. How are you going to group these? Game or g.game ID. Why? Because I want all the GTA 4s together, all the GTA 3s together, all the whatever, right? There we go. So GTA 4 is available on 2 systems. I told you to pay attention to that and remember it. GTA 3 is available on 0 systems. Zelda is available on 1. Looks like Portal 2 is available on 4 systems. And then all those Pong records that we inserted at some point, of course, we never inserted any availability records. So 0 for all of those. Right? So 2 queries to achieve what a couple hundred lines of Java achieved on your first assignment. Right? Much, much easier with a relational database management system. We started there. How did we design this database? Right? So let's talk about that now. Right? In fact, we're going to design our own database. What do you want to do? I'll make sure that all those are over there, by the way. We could just, I think in the pre-prepared videos, tutorials, I do an author database, authors and books. In your lab, you'll do albums, records, and musicians and stuff like that. We just did video games. The other go-to is usually films, actors, directors. So what do you want to do? This one's good enough? All right. All right. So design a database to model films, actors, and directors, right? So semantics dictate design, right? You usually have one table per entity. There we go. Dictate design. There we go. Got to spell it right. Where have we heard that before? Semantics dictate design with respect to classes, right? If you were designing your next phase here, how many assets do you have? At least 3, right? What kind of assets do you have? Stocks, cryptocurrencies, property. Is that it? Options. And in fact, you have 2 types of options, puts and calls, right? So that's at least 6 there, plus the abstract class above, plus maybe some other classes. It depends on how you want to go about doing it. You can put this all into one big giant hierarchy. You can put it into a dual hierarchy. I wouldn't recommend that. You can use composition in some cases, right? For example, if you have a put, right? Well, that could be an option, and an option is a stock, right? You can have that entire inheritance there. Or you can have a put that owns a stock instance through composition, right? And you get all the same information without locking yourself into a hierarchy. There are at least 3 or 4 different completely fine designs. Some of them will, the simpler designs are generally better. So keep it simple. KISS, right? Keep it simple, stupid. That same design principle as before. But here, semantics dictate design. So if I want to model something with films, actors, and directors, how many tables at least do I need? 3, right? 1 to a table. It's called normalization. We'll go through the formal normalization process later on. Don't worry about that just yet, all right? Let's talk about style tips, though, right? When creating tables, use consistent naming conventions. Right? For example, don't pluralize your tables. Right? So instead of the films table, I will have the film table, and it contains film records. Right? That's where I pluralize. Why don't you want to pluralize something? First of all, it doesn't make any sense. Does anybody in here say, oh, let's query the films table? That doesn't sound right, right? But also, what's the other problem with pluralization in English? Inconsistency. Sometimes you add S. Sometimes you add ES. Sometimes you change the Y to I and add ES. Sometimes it's a completely different word. Sometimes there are multiple words. For example, person. What is the plural of person? People. Right, completely different word. Or what's another one that's perfectly acceptable? Persons, right? What about axis? What's the plural of axis? Axes, right? Weird, right? Completely different words sometimes. So don't worry about it. Don't pluralize your tables. Keep them singular, right? Generally use upper camel casing for table names. Right? And use lower camel casing for column names. Now, that I say generally, as long as you are consistent, you can use whatever the hell you want. I don't care. Right? Why am I suggesting to use upper camel casing and lower camel casing respectively here? It mirrors your objects. It mirrors your classes in Java, right? So when you go to make a connection between that stock table and your stock class, right? Do you have any guesswork as to what the names of the columns should be? Nope. One-to-one correspondence, right? Name primary keys after the table plus an ID, right? You can also use underscore ID. Again, don't mix types, naming conventions or whatever. Name foreign keys exactly as the primary keys they reference. So we'll have a couple more here, but let's go ahead and start with our very first table. Right? So which one do you want to do first? Films, actors, or directors? I don't even know if come on, cancel. All right. I'm going to type it over here just so that I have syntax highlighting. Cancel. I'm going to type it over here so I just have syntax highlighting, and then we'll go ahead and cut and paste it into the command line stuff. All right. So when you go to create a table, what keywords do you think you use? Create table, right? And we need to give that table a name. So let's go ahead and start with the film table, FILM. Right? I am using upper camel casing conventions. I'm keeping it plural, just like we suggested. Opening parenthesis, closing parenthesis, and it ends with a semicolon, just like many other programming languages. Everything that you put in here is going to be a column, and you delimit columns with commas. All right, what defines a film? Again, semantics dictate design. Go away. Semantics dictate design. So what is a film? Think of the last film you saw, movie that you saw. What's the last movie I saw? I think Dune in the theater. Geez, that was like, what, 5 months ago? Right. So what is Dune? It's the title, right? And the title is a what? It's a string. And strings in SQL are varchars, variable character arrays. And you do have to provide a limit, right? Or you can have there are others, you can have say, food text, you can have short text, you can have long text, right? And those have built-in meanings with specific lengths, I think like 4K, 4 kilobytes or whatever, right? Don't worry about that. We'll just go ahead and say 255. 255 characters is more than enough to model any film out there, right? All right, what else makes a film? And it's not it's complaining at the end right now because I've got that comma. Right? Once I get rid of that, then it's fine. But I want to do some more here. So what else makes a film? A what? Genre? Okay. Genre. Yeah, that's right. That's spelled right. All right. Give me an example. Dune is sci-fi, science fiction, right? Bridget Jones's Diary. There we go. What genre is that? Romantic comedy, I think, right? Yeah, whatever. Terminator 2, action, etc. So we could say that this is a varchar and then make it significantly smaller, say 100, right? But then maybe we want to do genre and subgenre, right? Science fiction, sci-fi fantasy, sci-fi, hard sci-fi where, it's more grounded in science, in current science, et cetera, right? Near future stuff, right? What is that an argument for if you want to get that fancy? Creating another table to represent that genre. Right? All right, I don't want to go that far yet, though. Right? Say what? Okay, the year, right? Or release year. And there is time, and there is date, right? Don't use them, right? Release year, or let's just go with release date. I'm going to make that into a varchar as well. The reason being, dates and times, those are not interoperable. If you take a date and a time formatting from MySQL, MariaDB, and you move it over to Postgres, or you move it over to SQL Server, it will break because not all of them represent time the same way. How could I represent time in a universal way? Using that ISO 8601 standard, right? That you should get in the habit of using, by the way. It's always the year, and this is a comment here. The year hyphen, today is the 3rd, is the first, sorry, first, March 3rd, March 1st, excuse me. And then the time, what time is it right now? 12:00:54, 1 second ago. And then there's a GMT offset, so we're in the CDT time, right, etc. Right? That, okay. How do you know if a movie or a film is good or not? You watch it, right? A rating, right? IMDb ratings, or Rotten Tomato ratings, or whatever. IMDb ratings are rated on an average of aggregate reviews on what scale? A, B, C, D, E, F? Or F? No, does anybody know? Nobody goes to IMDb. 1 to 10? So it will be a double. Right? Same keyword that you would use in Java or C or whatever. Right? There are floats. They're just less accurate doubles. There are, decimal, where you can specify that I want a certain number of digits of precision along with a certain number of decimals of precision or whatever. Don't get fancy. Doubles are good enough. Right? What else defines a film? How do you uniquely identify a film? Well, how do I uniquely identify a record in my database? With a? How do we do it over here in the game database? What was this thing called? What is this little tiny symbol here? What does it look like? A key. Right? So let's make a primary key. Primary keys should be named after the table that they are in. So film ID, film plus ID. And it will be an integer. You can use int or you can use integer. It doesn't matter. Those are aliases of each other. Int, primary key, 2 words, not null, auto increment. That should be your go-to, the first thing that you do in every single table. What that does is it establishes a primary key. It cannot be null because you have to have a way of uniquely identifying every record. If you allowed it to be null, which is actually the default, if I didn't have that, it would one record would be allowed to be null. One record and one record only, right? Why? Because it's a primary key. You can't have two records in here with primary key 1, 2, 3, 4, 1, 2, 3, 4. Likewise, if one of them is null, no other record can be null. So it's kind of useless. So I'll make this into a not null. Right? And then auto increment, there is an underscore there. Yes, it is inconsistent. Don't ask me why. That means that the database will take care of it for you. If you remember when we inserted new records, right? We could specify the primary key, but if it conflicted with an existing record, it rejected that. We weren't able to do it. Auto increment means it'll take care of it for us. We don't have to worry about it. So whenever you create a table, the first thing that you do, primary key, integer, not null, auto increment. You could have variations. You could make it a double if you wanted to. Is that a good idea? Probably not. Right? Is 0 equal to 0? Not always. 1 divided by 3 is as a floating point. Times 3. Is that equal to 1? Nope. 1 divided by 3 is going to be 0.33333333, and then at some point it stops with the precision, and it goes 4 or 2, depending on how you do it. So if I add that to itself 3 times, do I get 1? I get 0.999999, and then drops off, or I get 1 just slightly above 1. Right? When you go to start, matching things to another table, you want precision. You want exactness. Only integers. Right? You could do varchars. But now what are you doing to match this film to this director over here? You're doing string matching instead. Which do you think is more efficient? Checking whether or not 2 integers are the same, or checking whether or not 2 strings are the same? Integers. Not only that, but all of the confusion, all of the issues with respect to casing, right? Foo, all caps, is that equal to foo, all lowercase? Maybe, maybe not. It depends on the database defaults, how the table was created, your queries, et cetera, et cetera. There's a whole list of stuff that it depends on. Don't worry about it. Keep it simple, right? Integers. Film ID, int, primary key, not null, auto increment, done. Right? What else? Anything else? Outside of our own database, how are films identified? Does anybody know? I think we did this with like Computer Science 1 last semester, and I pulled it up. Do you remember this EIDR, I think it is? EIDR. There we go. A universal unique identifier for movie and blah, 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 whatever else, right? And television assets, right? It's similar to with books. You have an ISBN, right? An international whatever book number or whatever. EIDRs are where you can register media, like if you made a short film or something like that. You could go and you could register this. It probably costs, ISBNs cost. If you self-publish a book, you have to buy an ISBN. It's not that expensive, but each version that you come out with, like each new edition you come out with, you have to pay for another ISBN. Because they handle the registration of all these things. What does an EIDR look like? I don't know, EIDR for Dune, right. 1980. All right, well, at least maybe Wikipedia will at least show us what one looks like. All right, there. It looks kind of like that. There's the canonical form. So is it a number? Is it an integer, like my primary key? Nope. It would be representable as a string. Go away. So we can put that in there if we want, EIDR. All right? And that's going to be a varchar of, I don't know how big it was, but 255 seems big enough. All right? But think about this design here. We've got a primary key that uniquely identifies every record. We've got an EIDR that uniquely identifies each record. Do we need both? Do we need a way of making this? First of all, as a primary key, this is guaranteed to be unique because the database takes care of it for you. But is this guaranteed to be unique as I've got it here right now? Nope. So what we're going to work on next time is I do want to make the EIDR unique. And then I want to have a little bit more consideration here. I've got 2 ways of identifying something. Is that necessary? Is it a good thing? Is it a bad thing? Right? And we'll discuss that on Thursday. But otherwise, your lab tomorrow is just basically doing all the queries that we did, but on an albums database instead. So if you reproduce what we basically, and in fact, we went a little bit beyond what you'll do in the lab tomorrow. And again, note that you should get set up with your account as soon as possible. You do that by going csc.unl.edu, account, log in with your CSE login. Once you're in there, you go to account settings, and under MySQL password, it'll send you an email with a reset password. You can change it to whatever you want. Again, do not use a password you care about. You will eventually be sharing it with graders. You'll eventually be sharing it with your partners if you're working together. All right. See you on Thursday.